after Apollo first landed. We will need more data and perhaps some new theories before the origin of the moon is settled to everyone's satisfaction. When a scientist says, I need new theories, what is he admitting about his current ones? All right. Now, as it turns out, right about the same time, actually, in the mid-70s, there was a new theory proposed. Right? That's right. Earth was hit by one of those big asteroids, in this case a really, really, really big asteroid, roughly the size of Mars, incidentally. It came along and hit the Earth early in its lifespan, if I can apply life to a planet. And the material sprayed out into space. Some of it fell back to Earth. The rest of it coalesced into the moon, where we see it today. That's basically what I just said. Now, computer simulations have proved this to be true. And if you poke around on the web, you can actually see some nice graphics from computer simulations and so on, showing you exactly how all this happened. Well, here's some problems with that. Number one, it's not proof at all. It's just a story, right? I can concoct all sorts of stories, but that's not proof of any kind, right? Number two, it's not even necessarily a good story. Computer simulations are approximations. Trust me on this one, from someone who's written computer simulations on space vehicles and such, you can think your thing is working just peachy and producing all kinds of good results, and no. It's very difficult to write a simulation. Because think about it, you're trying to simulate something that's never been seen, observed, or can't be simulated in any laboratory. How do you know if the computer is producing the correct results? Well, the way you do it is you try to run some test cases through it first of things that you know are right, but very difficult problem. And computer simulations are by their nature imprecise anyhow, especially when you're modeling things on an astronomical scale. And I won't bore you with details, but that's a whole subject in itself. In this particular case, also, the computer simulation shows that everything had to be just right. You had to have an object of exactly the right size that came in at exactly the right speed and hit the Earth at exactly the right angle for it to even come close to working. So even if it was possible, it's very, very improbable. There's another question, though, and that's why doesn't Venus have a moon? If this all happened by itself because all these asteroids are flying around, right, then Venus, which underwent all the same processes that we did, made from the same stuff at the same time, in the same place, by the same processes, should be similar. Then we would expect it to have some kind of moon, right? If this was so inevitable that we got one. But Venus doesn't. Another problem with it is it requires the moon to have been formed 4.5 billion years ago, which incidentally is the age that you'll hear that the moon is if you look this up. But the moon can't be that old. Here's why. One of the things that the Apollo missions did, other than, they left some things behind besides footprints. And one of them is these light reflectors here. We've left several behind, and the Soviet Union actually, in some of their unmanned probes, left a couple behind too. Here, these are the locations on the moon where these things are sitting. The purpose of these was to be able to bounce laser beams off of them from the Earth and have the light come back. Now, this is a very hard thing to do, as you can imagine. They're doing this today still, and it's successful when they get a few photons of laser light back. I mean, it's a really tough problem. But in so doing, like I said, they have been doing this for years. They've discovered that the moon is actually receding from the Earth. As we've been bouncing lasers off it year by year, we're measuring the amount of time the laser takes to leave and come back. And we've discovered, as I said, the moon is actually moving away from us slowly over time. Let's see, do I have another slide on this? I do. The moon is actually receding from us about 1.5 inches per year. Now, that's not a whole lot. Excuse me. But think about this. If it's moving away from us year by year, then if you look backwards in time, year by year, it's closer to us, right? Now, work that back, and the way the math works in this, actually, why don't I explain how this is working, first of all. It has to do with tides. The moon is out here, the Earth is here, in this high-tech diagram. And this blue thing here is a tidal bulge. Tides are caused by the moon's gravity pulling, in this case the ocean, toward itself, so that the ocean is actually thinner here and thicker here, thus this tidal bulge. Now, what's going on, though, is that the Earth is rotating underneath this tidal bulge. So the Earth, as it rotates, friction between the ocean water and the Earth is going this way and actually pulling this tidal bulge up slightly. Okay? So the tidal bulge is always being pulled up, so the tidal bulge is actually displaced. That's more like over here. Excuse me. As a result, the moon is being affected by this because that bulge actually has a gravitational force of its own, gravitational field, I should say. It's not much, because it's just a big blob of water, but it is having an effect on the moon. If it was lined up with the Earth, like I have my diagram here, then it wouldn't be a problem. But because the Earth is always pulling it a little bit forward, there's more of it over here slightly than there is down here. And so the moon is actually being pulled this way as the tidal bulge is being pulled that way. Does that make sense to everybody? So the moon is actually being accelerated slightly in the direction of its orbit. And the way orbital mechanics work is if you accelerate something in an orbit, if you add energy to it, the orbit gets bigger. So the result of all this is that the moon is moving away from us slowly each year. Like I said, about 1.5 inches or so. But work it backwards. The closer the moon is to the Earth, the stronger this effect gets because the objects are all closer to each other and the gravity is stronger. So if you work it backwards all the way, it turns out the moon would have been touching the Earth just 1.5 billion years ago. And we know that didn't happen. I mean, nobody accepts this, is trying to say that it did. There's reasons it couldn't even get close to the Earth. It would be pulled apart by tidal forces, but that's not important what we're talking about here. Point is, the moon can't have been in its current orbit doing what it's doing for 4.5 billion years because 1.5 billion years ago it would have been touching us, which would have been bad for it and us, incidentally. One more thing with the moon. For several hundred years now, people have been observing the moon through telescopes and whatnot and been reporting various things happening. These have been assigned the name transient lunar phenomena, or TLP for short. A TLP is when somebody is looking at the moon and notices something that shouldn't be there. It usually takes the form of a smudge appearing on the surface of the moon that dissipates after a while, or a glow appearing in a region somewhere that goes away, even a flash of light or something. Now, these things only last minutes, maybe hours. They don't last long enough to get a good telescope trained around on the moon and take a picture of it, which is why we don't have pictures of this stuff going on. That's why they're called transient, because they pop up and then they're gone before anybody has a chance to look. Now, for a long time, now, back up a minute. I'm not saying that there's aliens on the moon, flashing spotlights or something. I'm not saying that at all. What people have believed is going on is that there's volcanic activity on the moon, that if you have gas coming out of a vent or whatever, it's going to kick up a big cloud of dust. You're going to have electrostatic discharge, lightning basically, going on inside this cloud to dissipate the charge, and then it all settles down again. So the basic explanation for these things is that the moon is geologically active. There's volcanoes, small volcanoes going off and whatnot. The problem is that the moon is supposed to be 4.5 billion years old. It's old, cold, and dead, basically. It can't be geologically active because something as small as the moon would have cooled off a long, long time ago after it was formed. It can't have energy left over. Now, something as big as the Earth can retain enough heat, and it had more to begin with. So volcanoes on this planet doesn't bother anybody. But volcanoes on the moon can't be there because that would violate the old, cold, and dead description of the moon. However, NASA was finally forced back in 1968 to come out with this document called the Chronological Catalog of Reported Lunar Events, which documented 579 different instances of TLPs going on. Just for your interest, I have a couple pictures of the places on the moon where these things have been reported. This is the Gassendi crater, and the Aristarchus plateau especially have had quite a few of these incidents reported for them. Again, we don't have pictures of these things happening, which would be nice if we did because it would diffuse this whole debate. I mean, there it is. But apparently it's very real. The problem is it violates the old, cold, and dead principle. Well, maybe it's not old, cold, and dead after all. So here's what you aren't being told about the moon. There's problems with its origin, severe problems. Trying to explain how this thing got there is not at all what you're being told. Lunar recession says it can't be billions of years old because 1.5 billion years ago it would have been touching us because it's moving away today. And transient lunar phenomena also say that apparently it's not old, cold, and dead as it is supposed to be. So the moon is uniquely designed for us, basically, as a summary of all this. Actually, I just put this in there because I like the picture. So, next planet out is Mars. Are we going too fast? Am I throwing too much detail at everybody? Yes? No? No? Okay. Next out is Mars. Mars is one of the few objects we have actually landed spacecraft on and sent back pictures. Here is what the Martian landscape, at least in one location, looks like if you were unlucky enough to be stuck there.